Okay, so the Cartesian equation of a plane. It's written as ax plus by plus cz plus d equals 0. Very similar to our Cartesian equation of a vector or a line. The only thing they didn't have before was our z and d. They just called it ax plus by plus c. Right? Same idea. The only difference is we're in 3 space here. Our normal is the numbers a, b, and c. Okay? And the normal can also be found by taking any of the 2 vectors on this plane and finding the cross product of them. Remember, cross product will help us find lines that are perpendicular. Okay? So, what we're going to do here is quickly show you what we mean by the normal of this plane. If we're in 3 space, x, z, y, and we have some plane in 3 space with us here. We'll try to do the plane on an angle. Oh, can I? Okay, I'll try tilting it after. Thank you. That was becoming very difficult. I think the green thing spins it. Oh yeah, there we go. Okay. That might be okay. So let's say we have some plane in 3 space. Sorry, that took a bit. Our normal to this plane. Our normal is going to come from where? Anyone remember? It's going to be perpendicular for sure, but there are an infinite amount of perpendicular lines to a plane. This one normal has to come from a specific point. Anyone know where that point is? It's got to start somewhere. That's right, the origin. Oh, you got it. So, the origin. It's got to start from the origin, this perpendicular line that's going through this plane here, okay? So, let's imagine that this crosses at something like that. That's where it pierces the plane. It's got to start at the origin, our normal. So, our normal vector starts at the origin and is perpendicular to the plane. It's important that it starts at the origin so that our normal actually has a direction to it, okay? Otherwise, we could just have it start anywhere and have an infinite amount of perpendicular lines to this plane. So that's the idea of this. Once we find our plane and we can find the cross product of 2 directional vectors along this plane, let's say we have direction vector A again, right? And another directional vector B. Once we have that, we can find the cross product of those 2 directional vectors and it'll give us something perpendicular to that, okay? Which will be our normal. We'll have a directional vector of our normal. So, our very first question, we're going to jump ahead to the next page. Example 1 gives us a point that's on a plane with the normal and says to determine the Cartesian equation of the plane. So example 1, we have point A, which is at 1, 2, and 2. And it also has the normal of -1, 2, and 6. Okay? Determine the Cartesian form. So we need the Cartesian form in this question. Okay, so let's try to visualize what the heck we're looking at here. Here's our plane. We have a point on the plane. We'll say that's point A. And we have a normal to this plane. We'll call that the normal. Okay? And remember, the normal is actually, imagine this is 3 space here. The normal is coming from, there's that x, y. It's coming from the origin, this normal, okay? And the normal is represented at -1, 2, and 6. That's the directional vector for the normal. Well, this point where we're crossing here, we have our point here of the normal. It's going to be perpendicular, okay? We also need to find another point along this. It can be any point on the plane. So we're going to call it point P. once we have the point P on the plane, we'll essentially have 2 points on the plane and a perpendicular line to it. So we're going to call this vector AP when going through it. We know that from our dot product that the normal times the dot product of our AP point is going to equal 0. Okay? So we can plug our normal in. We know our values for the normal, -1, 2, and 6. But we don't have values for AP yet. We need to find a directional vector for AP, which means we're subtracting point P from point A. But we don't actually have coordinates for point P, so we're going to call it X, Y, and Z. So our X, Y, and Z are our point P. And when subtracting them, what's going to happen is our point AP, because we always take the second point and then subtract the first point, is going to look like this. It's going to have X subtract -1, so it'll be +1. Y subtract 2. Wait, is that point A? Whoops, sorry, I was writing the normal. Point A is 1. So A subtract 1, Y subtract 2, I apologize, and Z subtract 2. That's our point A. I was writing the normal out. So when we go to do the dot product, our AP is X minus 1, Y minus 2, and Z minus 2. They all equal to 0. Okay. Now we know the dot product of our component form. We take the X values, multiply them, then add it to the Y values multiplied, then add it to the Z values multiplied. So we have -1 times X minus 1 plus 2 times Y minus 2 plus 6 times Z minus 2, all equal to 0. We substitute, or we distribute, our scalars. -x plus 1 plus 2y minus 4 plus 6z minus 12 is equal to 0. We're going to move all of our values here. -x plus 2y plus 6z. And then we have plus 1 minus 4 minus 12 equals 0. Well, these are our A value, our B value, and our C value. Okay? And then we just have to figure out the D. So -x plus 2y plus 6z. And 1 minus 4 is -3 minus 12, -15 is our D value equals 0. I want to draw your attention to the normal. Remember, they already gave us values for the normal. The normal was -1, which is our A value here. 2, which is our B value here. And 6, which is our C value here. Okay? So because we had that normal, technically another way, if we had recognized that we could have solved this question, was taking the normal. Might have been a little faster. If we had taken the normal, put it directly into Cartesian form, and then plugged a point along that plane in. So what I'm trying to say here is if we had AX plus BY plus CZ plus D is equal to 0, we knew the A value would be -1, so we have -x. The B value is 2, so 2y. And the C value of the normal is 6, so 6z plus D, which we don't know, is equal to 0. Well, our x, y, and z now represent any point or coordinate along this plane. We know the A coordinate. The A coordinate from the beginning of the question was 1, 2, and 2. So this is a different method of solving this question. We could plug those in for the x, y, and z, and then solve for D. So A was 1, so that gives us -1 plus 2 times 2 plus 6 times 2 equals D, plus D equals 0. Gives us -1 plus 4 plus 12 plus D equals 0. This gives us 15 plus D equals 0. D equals -15, which is exactly what we found in our other version. The one on the right might be a lot faster for some of you guys. The one on the left helps conceptualize the idea of what we're doing.